Yeah, we are looking at the method of variations of parameters, okay, to find the particular solution for non-homogeneous differential equation. Okay, in the last video, okay, we've discussed the undetermined coefficient to find the particular solution. Okay, for sine, polynomial functions, cosines, or multiple of them. So we've used undetermined coefficient to do that. Okay, but in this method, variation parameter, it works for any functions, and I even say it's even faster than undetermined coefficient. But we must learn all those methods. Okay, so this is another method also to find the particular solution, okay, of non-homogeneous differential equations. And how can we find yp, okay, of the second order differential equation, okay, non-homogeneous, okay? So you can see now this is the second ordinary differential equation equal to f of x. So how to find the yp? Step one, you find what? Two linear independent solution, okay, for the homogeneous equation. Okay, that means the first thing you have to do, you have to get what? You have to solve the expression homogeneously, okay, by equating that differential equation to zero, so that you can get two linear independent variable, okay, and that will be y1, y2, okay. And then from there, you can get the homogeneous equation. Once you get your y1, you get your y2, you can get the homogeneous solution for that. And that will be c1 y1 plus c2 y2. I know you all know that. Then the next thing to do now is to now find the yp of this differential equation equal to what? Equal to f of x. Okay, and don't forget also, even in the other methods, in the undetermined coefficient, the first thing, step one, is to get the what? Is to get the homogeneous part, the YH, okay, of the equation. Okay, then after that, we now take YP. It has this formula: V1, Y1, okay, plus V2, Y2, where your V1 as a function of x is equal to integral of what? Integral of the minus could be outside minus f of x y2, okay, all over a times the Wroskian of y1 y2, then dx. That's that. And your v2 as a function of x is equal to f of x y1 a, the Wroskian of your linear independent solution y1 y2 y1 y2, and then what's dx. So dx, okay. So or we can just also note there your y2 also is also a function of x, your y1 also is also a function of x, okay. And don't forget, when you're talking of v1, then you have y2 here. F of x will be involved in those two equations. When you're talking of v2, it will be y1, okay. The Wroskian value that is here is also the same thing, Wroskian value that is in your v2 also. And then where does the a come from? The a in virtually is always 1. Okay, a comes from, look at your differential equation. Whatever the attachment to your second differential equation is your what? Is your a. The attachment to your second differential equation is your a. But virtually all questions I've seen is 1. Okay, it's always 1. Okay, so that's that. And your f of x, you know your f of x is there. That's your f of x, and that's the non-homogeneous part. So that's that on variations of parameters. Okay, the only thing is just that you must be very good in your integration. Okay, and that's that. So let's go to questions on this aspect. Let's go to question. So this is what we have: a sub second differential plus y equal to tan x. If the question if you're not instructed on any method to use, okay, you can choose the one you like, okay. But some question will specify that use Bayesian parameters. Some question will tell you use undetermined coefficients. But if you are not told, the ball is in your court to decide which one you want to use. Okay, the first thing to do is to get the YH of the solution. YH of the solution will be equal to y prime plus y equal to 0. Now the auxiliary equation. Now the auxiliary equation will be equal to r squared plus what? Plus 1 equal to 0. I know we are aware of that. Okay, then let's get the root of the auxiliary equation. So r will be equal to what? R squared will be equal to minus 1. So r is what? Plus or minus. The square root of this one is what? Is I, the complex number. Okay? If you point your calculator, it will give you error, but it's I. Okay? Then with this now, we need to get the solutions of this differential equation. We get the y1. So, and don't forget, we have discussed this many times in previous video in the undetermined coefficients. That when you have the complex roots, okay, complex roots, there must be alpha, there must be beta, it must be in this form. But in this case now, your alpha is 0, yeah, plus or minus beta I. Your beta in this case is the coefficient of your I, which is 1 here. So if you want to do that, your y1 will be equal to what? E0, your alpha is 0, x cos what? Cos 1, cos x. So I'll not waste time. So 2 will be equal to what? Sin x, because the moment you have e this one should be e also 0x. So and this will become 1. So y1 is what? Sin x. Y1 is cos x, and y2 is sin x. So the homogeneous equation is what? Is equal to c1 cos x, and then c2 sin x. Don't forget, my y1 is what? My y1 is cos x. Okay, and that's why we said we should what? Find two linear independent solution for the what? For the homogeneous equation. Okay, and we have done that. Okay, then the next thing to do to find the YP, you need to get the Wroskian. I didn't even mention that. So we use your Wroskian of the homogeneous, of the independent linear independent solution. Okay, so we're going to do that right away. YP is B1 Y1, which is what? Cos x, plus B2 sin what? Sin x. Detail. Yeah, B1 Y1, B2 Y2. Okay, so that's that. Then after that, we can get the Wroskian of that function of y1, that's cos x, and then sin x. So which is equal to what? Determinants. That's cos x, sin x. Then the differential coefficient of this is minus sin x. The differential coefficient of this is what? Cos x. So find determinants. So this will go this way, cos square x. And this one will be minus into bracket this one times this one, minus sin what? Sin square x. And that's what? Minus times minus, that's plus. And that's 1. Cos square x plus sin square x is 1. Okay? And we check your differential equation. You can see the attachment to your second differential equation is 1. So your A is 1. So we just need to get the B1 and B2. And once we get the B1 and B2, then we can come back here and substitute. Okay? So let's get the B1. B1 is equal to, as a function of x. B1 as a function of x is equal to integral minus f of x is there. That's tan x. Okay? That's tan x. Tan x. Then times y2. My y2 is what? Sin x. Sin x all over. A is 1. The Wroskian also is also 1. Then dx. So what we have to do is just to try to break down this expression. We can take the minus outside, and that will be equal to sin x over cos x. That's for the target, and then times what? Sin x dx. And that will give us That will give us here minus into bracket or sine what? Sine square x over what? Cos x. Okay. So we now have before we can continue, we need to substitute for this sine square x, which is what? 1 minus cos square x over what? Over cos x. So that let's make everything to be in form of cosine. Let's make everything to be in form of cosine, then dx. And the meaning of this is what? It means 1 over cos, that's a sec x, and then cos over cos square x over cos. That's what? That's minus what? Minus cos x dx. So all we did now is just 1 over cos, okay, minus cos square x over what? Over cos x. So that was I did. That's what that's been done. Okay, 1 over cos is sec. So and then this will mean integral of sec x. Don't forget there's a minus outside. There's a minus outside here. So let it open to the minus sec x, and then minus times minus, that's plus. That's integral of cos x dx. Integral over sec is a table, so that will give us minus ln sec x, which is a direct table, tan x. Okay, and then sec x tan x, and the derivative of integral over cos is plus what? Sin x. Okay, that's my b. That's my b1. Okay, integral of sec is ln sec x plus tan x. Then let's get v2. v2, the formula is what? Integral. There's no minus there. That's f of x, and the y of y1 as a function of x over Wroskian of the function. Okay, dx, and that will be equal to tan x. That's tan x. F of x is tan x, and y1 is what? Sin x. The Wroskian is what? 1. 1 times 1 is 1, and then the other one is 1 dx. Okay, so what do we do now? And this will be equal to tangent is sine over cos. What's happening? Y1 is what? So sorry, y1 is a cos. Y1 is a cos x. Y1 is a cos x. That's cos x. That's y1. Check. Yeah, that's y1. Yeah, that's y1. That's cos x. Okay, so that will be equal to times cos x. So cos will cancel, then dx. So integral of sine, that's minus cos x. We will not put a plus c in this case. Okay, plus, we will not put that. So then the yp, we just substitute. We have said that v1 cos x. What are v1? We have it there. Times what? Times cos x. Okay, so that will be cos x. Then open brackets. That's my cos x here, times v1 minus ln sec x plus tan x. Okay, close that. Then plus what? Plus sin x. So this can be a bigger one, like this. That's a v1, y1. Then plus v2. v2 is minus cos x, and that'll be plus what? Plus v2 minus cos x sin what? Sin x. So automatically this plus here we cancel. So that's our answer. We don't need to do any arrangement, just leave it that way. So that's the answer for that question. Okay.